If you ever felt some appreciation for PDF files that are also valid programs for the Apollo guidance computer, then you are in the right room. Ange Albertini is doing talks like this and did a very similar talk 10 years ago called Following Funky File Formats. And we are very happy that he's back now with a fresh heap of file format weirdness. Give him a very warm applause.
Hello. So, hi everybody, and welcome back 10 years later. So, how many people of you were here 10 years ago? Let's see, raise hands. Ooh, thank you, awesome. Okay, so still interested in file formats, that's me, looking at hex editors and doing all kinds of stuff around file formats. But instead of speaking about me, let's look at a file and let me know what you think. Yes, it's empty. So, can an empty file be useful? Can one find purpose in emptiness? Besides crashing code in production, YouTube, stopping malware installation, shutting down botnets. Okay, but seriously, there's no way the empty file could be used in standard, right? Any idea? Being true used to be empty because it's an empty shell script. It always runs successfully. It's valid source code. And it runs. It used to be true, used to be empty, and it also works. It saves space, and even became copyrighted because of its comment. Nowadays it's an elf, but being true used to be empty, so void is weed, like Baba would say. In DoomWads, empty files are used as a map index in the file system in the archive table. So here, E1, M1, to just say the information about the map starts here. Void is here. And under DOS 1.0 and CPM, launching an empty file, there was no check for file size. So if you would run an empty file, it would be executed like x86 assembly, and it would run whatever was in memory until that point. And because memory wasn't cleared, then the previous software was executed again, and it was even sold. So it's like infinitely profitable program of empty size, and it runs, and it was sold for that. So void is last. So we are just empty file, no content at all, and already we have like, it can be sourced and run successfully. I mean, it was on every system, right? It's an index on Doom archive, or it's an executable of supposedly x86 program, yes it is, and it actually works reliably, repeating the last commands. So among, of course, many possible other things, but those are standards. So we have not defined any content, and yet the type and context and purpose are already unclear. So a file has the contents, but context and metadata can also be critical. Now, let's look at files, at something else, because after all, what are files? And video games is actually a good way to see how the concept of files was introduced to standard users. And long ago, when memory was too expensive, we used to save data with passwords in video games and not actually saving a file. Then, in this game that you may know, then they were saving data, but there's no file system, it's just hard-coded offsets in the system. And now it's actually very interesting that around the 90s, they changed from player select to actually mentioning files. So it's for the people, for the standard user, gamers, they started mentioning files technically, officially, instead of player, even if there was clearly no file system, but it was already around the 90s, right? That people, video games started to introduce the notion of files to everyone as a standard. Now, let's look at something else. What's a file without a format? And wait, what does that even mean? And why would you do that? Okay, there is this company that you may have heard of, and a bit before Microsoft Word in 1984, same company, yes, the same Word that is still in the office nowadays, I mean, just slightly updated. It used to say it didn't use a file format. It was just snapshotting the whole memory range with whatever else it was in memory at that point. And it's just simpler. It's not finger pointing, it's just the standard way it was simpler back then to do that. using a file format was completely irrelevant because there was no need to share files, and there was no interoperability, and it was just faster to just save everything and just reload whatever was in memory. So a simple hello world actually takes the whole page of 512 bytes because it would just save the memory page with whatever was in it. So how do you reliably handle such files? That's a very good question, and I wish I have a good answer for that one. Because, of course, there is absolutely nothing like a format. It's a file, it's Microsoft Word, but there's no format. Ooh. So a small introduction to file format landscape in general is that, similar to this, it's full of nasty surprise, exception oddities for whatever reason, historical or technical. Okay, my first initial rant is that we need to preserve file formats in a better way. What's the aim of file formats? Maybe we'll answer that later. Now, 10 years after a funky file format, hopefully everything is fixed, right? Maybe not. So ambiguous files are still there. They're still not reference parsers. Of course, there are test corpuses and reference parsers for some file formats, but definitely not. There is also the problem that specifications can be very expensive, so basically devs don't pay for them, and basically YOLO. They try whatever they can and take shortcuts to just implement stuff, and it's a mess. A simple example with a file specification, is, how do you pronounce this name? Anje, Ange, Anzu, Enji, Ange. Is it male or female? In north of France, it's more for female. In the south, it's more for male. So, and it's same for names. There's no specification, and things get quickly messy. So, yeah, Ange, officially. In 2024, concatenation still works. Earlier this month in Black Hat Europe, they were hacking over the air many cars by duplicating a file entry in CPIO archive. And this is a format from 77. So sadly, the same old techniques still work. And here it's for hacking cars over the air. Just with a trick, I mean, not just that, but using a trick from a format from 77. I will, of course, speak about polyglots, but I definitely want to insist that most people remember me for making polyglots, but the file format landscape is much more than that. But yeah, still, it's me, so what do you expect? Some polyglots of various kinds, all in one, because why not? That's what I do over raining weekends. And I created a tool that's called Mitra, that just handles many file formats, just has many abilities, but it just does the minimum. It's not a deep scanner of any kind. But this is open, in public, of course, and I already presented about this in the past. Mitra does all kinds of stuff, and we will cover a few of those. Mitra can help you first to make space in a file format while keeping the validity. For example, to embed payload, for example, to do a PNG JavaScript polyglot. A bit like before, but this time you can automate it easily, and you can also do that with a lot format. Of course, you can make polyglots. Oh, no, sorry, you can, sorry, wrong slide. You can also insert fake signatures. Just you put some space, and instead you put a fake signature so that file identification will be fooled. And of course, you can do that automated with a lot of format. So you can have an empty file that has no payload, but 190 types. Mitra supports many formats with combinations that are not necessarily possible if the same format start at offset 0, have to start at offset 0. There are ways to bypass that in some ways that we'll mention later. But yeah, it's still important to have formats that don't start at offset 0. That's all start at offset 0, sorry. And of course, this is just the main type. So when there is zip, when there is doc files, when there are a lot of formats that are used for something else. So it's actually a lot more, many more combinations of that. It's just the basic format, the basic structure, and a lot of subformat will be exploitable the same way. Not a polyglot done by Mitra, but it is one I like particularly, that you can abuse line comments on PDFs and insert fake lines of arbitrary data regularly. And it was used for the eFail attack by crafting a PDF that is a lasagna of arbitrary data and a valid PDF. I started a small tool that is called FileCraft that enables you to build files from the ground up. It's still very basic, but an example of what it can do is craft your zips from scratch. And for example, a common problem with file formats is that when you have twice the same information in the file, which one will be accepted? And very often there are problems that one information will be used for validation and one for execution. So basically you have a very reliable vulnerability. But with zip, with older structures, you can actually add up to at least 4 different names for the same file in the archive. And yet you see this is the total archive, it's very small. So now, concept that I kind of mentioned 10 years ago, but now is a bit official, is a near-polyglot. A near-polyglot is that it's almost a polyglot, so but there is some data that needs to be replaced by an operation. Of course, the smaller the data, the better. And will be it's not a valid polyglot as such, but there will be an operation that will swap the overlapping data from a format to the other. And the advantage of that is that it enables to collide, to combine some formats that usually wouldn't work together. And the other thing is that one of the payload is disabled while the other is active, so it's even more sneaky than a standard polyglot where both payloads are efficiently usable simultaneously at the same state. So then you can combine, in a near-polyglot, you have to replace some data. When you do that with a cryptographic operation, then call that crypto-polyglots. And the operation can be an encryption or decryption with specific parameters. Sometimes you may need brute forcing, we will see that. And again, now that one of the payload is actually completely encrypted and you maybe don't know the key in advance, then the other payload is much more hidden. But actually, I covered that 10 years ago, kinda. So here is a small BMP PNG near-polyglots. BMP and PNG cannot coexist in the same file, but when you swap the first 16 bytes, then you turn one file into the file type into another. And this is basically encryption, which I presented 10 years ago, just in an official way. You use ASCBC with a specially crafted initialization vector, and then you will basically encrypt the file to another valid file. And as you can see, the payload, one payload is completely, it's encrypted or decrypted, but not in plain text, while the other is in plain text. But now we can do something more. This is a BMP PostScript near-polyglot. Here, PostScript can be only kind of, with some tricks, only requires 3 bytes of abuse, of overlap. And the smaller overlap of the 2 formats is the one that only requires, so here it's very small overlap because the start of an empty named function in PostScript enables to hide the BMP header. And now you can do that. You can do some other kind of operation, and in this case, both files are decrypted via ASGCM from the same ciphertext via different keys. So I presented on that. I'm not going to go through all of this. And you also brute force the nonce to generate the overlap with either key. What are the implications of that? Okay, under the hood, anyway, you don't need to understand that. Right now, I presented about that, and the tool is available. So Mitra and the key commitment tool. So Mitra is in Python, and key commitment tools are in Sage. And of course, our PDF article that was published with 2 operations for OpenSSL, it becomes a PDF viewer executable via authenticated encryption because, of course, you can forge an encryption tag so that 2 keys are valid. And this is exactly what's going on here. If you don't have a way to make sure there's only one key that is committed to the encryption, even with authentication, ciphertext can be crafted to decrypt 2 different payloads and be valid. And there were vulnerabilities in Facebook, Amazon, Google. And when you use that with key management in advance, then you can say, hey, here's the file that you want. But if you know what the next key of what the next key will be added to the encryption keyring, then you can forge some payload that will, when the new key is added to the keyring, it will be typically in the key management system, just try whatever key decrypts authentically. And here, you basically upload something, you give something to someone, it's a perfectly valid file, and then it's stored in an encrypted way in the backup, and the new later not malicious, but that you could plan in advance key is added to the key ring, and because the algorithm just tries every key until there is one that is authentically decrypted, it decrypts to something else, and it's all perfectly valid, and there's no hack. It's just how crypto works. So basically, you can say, hey, you want this article, here is it, and later it becomes WannaCry. And of course, you can do that with Mitra or tools without having access to any source file. You can operate directly on the final binary, and both files will be valid. So this shows that you need a key commitment to make sure that even if it's AES-GCM and other encryption modes are used, authenticated encryption mode are used, then this is not a bug. This is just how it works, and you can add up with a different payload than what you initially think you received. So this is a small reminder of what's the hierarchy between all the weird files. So if it's just a magic, then it's a polymock. Then if it's same format, then it depends. If it's full format, but the same format is just an ambiguous file, then polyglots and near-polyglots, depending if there is some overlap or not. Now, but when you have this super complex authenticated encryption stuff, it's like, wow, this attack is coming out of nowhere, and it's not something that concerns me. And the thing is that nowadays with cloud, a small bug with the amount of users and the speed of people communicating, a leaked credential can be abused within minutes. And basically, a single minor bug can affect billions of users for privacy or for leaks of important information. And PNG is a very clear defined format since a long time, and yet, very small bug. The Apocalypse in 2023, just standard PNGs that were cropped by the user, and the Google Pixel and other software were leaving the leftovers data. And basically, you were leaving some private data not in plain sight, but in the file that could be revealed later. And because it affected every user, it was a major leak. So it's just, you save to a smaller file, but you don't truncate the file, and suddenly it's a major information leak for users everywhere. So even though the PNG file format is very clearly defined and quite simple, to be honest. Another thing is about SQLite files in the wild. So SQLite is is used commonly for many things. They say that there are at least 20 different instances of SQLite files in mobile phones. I assume that would be more, but it's not surprising because it's good. And basically, it's used for whatever thing. So for example, Adobe is using that for in-product messaging, which is basically just a way for the software to know what it should nag you with as a message. So for example, your subscription is about to expire, your subscription is expired. This is the kind of message that is used in the SQLite database. The thing with SQLite files is that there is a very clear magic on the first 16 bytes, very strong identification. But then, what kind of data is actually in the file is much further in the file and not necessarily at the same place. And another kind of SQLite files, Bitcoin wallet. What could be interesting there? And same here, SQLite file, okay. They use the app ID, it can be identified. To be honest, it wasn't identified, but I submitted some patches to file, libmagic, so that now it's identified. And the SQL schema table is, again, unclear, but as you can see, the offset is very further in the file, so usually it's not identified. So basically, until very recently, those two formats, one, absolutely not interesting, and maybe it's worth clearing these files so that you have less nags when you start the application. And in comparison, your Bitcoin wallet, which is probably more important and more interesting, you would have no way to tell the difference. So basically, that's what I started to look out, and that's why I started a tool called SQL Buddy, which is just basically looking at the file, trying to extract the schema, and maybe tell you if it's like super important or totally not. And that gives you more idea of the risk of information leaks. Because SQLite is used like for crazy, I mean, not for crazy things, but cookies, web history, credit card, Bitcoin wallets. SQLite archives, SQLAR, is actually used for an archive system. Now there is a file system for that, so you could boot maybe from a SQLite file. What could go wrong with that compared to a standard information? Even photobook and other things are using SQLite format. So I created a small file to help distinguish at scale between all those files. And hopefully there will be more signature. I will submit more signatures to LibMagic so that all systems can actually tell apart this kind of file. So again, there's no file format trickery here, but there is a major risk of information leak. I mean, OK, Bitcoin wallet, please send them. I'm fine with that. So hash collisions in 2024. Let's start first with CRC32 collisions. Because some antivirus detect the ACAR file by CRC32 in 2024. So here is an impressive CRC32 collision, so that you can see that this file is detected just because it has the same CRC of the ACAR string. Wow, amazing. Who needs complex SHA-1 attacks or whatever when you have a CRC32 collision detection? OK, so I'm not sure how familiar you are with cryptographic hash collisions. They require acrobatic construct. And I gave a couple of presentations on the topic, including a workshop. The slides are public. All the proof of concepts are public. And yeah, also my contribution to the first SHA-1 attack shattered in 2017. So, and yeah, I have a repository where all this is available. And I gave this training a couple of times. So now that we proved that MD5 is really broken, what could go wrong, right? Oh yeah, sorry, I forgot to mention. Mark Stevens created a tool that actually is able to detect MD5s or hash collisions, even in files that are pretty unique, like the Flame unique collision. We don't have the other file. It was a known malware for using a very groundbreaking hash collisions back then. And even SHA-1 collisions are detectable with detect call. The thing is, detect call requires to scan the whole file, which can be power and time consuming. But it exists. At least there is a way to see them coming, even unknown ones. Hashquines is a very interesting way to show art with hash collisions. So basically, with hashquines, you add a lot of collisions so that you can change the displayed hash of whatever the file is, the file type is, but keep the final file constant. So we did that with PDF, GhostScript, GIF, PNG, Nintendo image, because why not? So it's a very nice way to show that MD5 is really a fun toy. And of course, no one would use it anymore. Another hashquine that I really like is by David Bohannan, the Retroid, where you can make a tar archive that will contain a hash list, which includes the hash of the whole archive. And via a script, you can actually, it's now that he computed 653 MD5 collisions, and we abuse these standard frames to do so, now you can actually use that generically. So basically, you have a tar archive, you extract the list of the hash of all the files inside, including the whole archive. It is kind of magic, and it shows that there is maybe something broken with MD5, but if it's not broken in practice, then it must be good enough. And in 2023, for the Radius protocol, which is using MD5, the conclusion was that, meh, probably it's safe because no one has really broken it so far. And there was a new attack this year, and that was presented this month, that, yeah, maybe it's actually broken. And now there is actually an update to this draft. But despite all these attacks and all this fun thing we did with MD5, then in 2023, people still say, probably it's safe, so, until broken. And in 2024, Mark Stevens also created the first text hash collisions. So basically now he can even start to make puns. So the hack turns into heck, which is totally not a coincidence. It's a 1-bit difference. It doesn't even require 64 bytes of data. Now, for example, you can test remotely when people is using MD5 for your password. Because basically you can enter one of the strings as a password, and the other string has the same hash. Even though it's pure text, there is some control that you have over the overall alphabet. And it's just 1 bit of difference. So it's pretty hard to detect. So that's the advance, the latest advance in the hash collisions 2024. We can start to make poetry in pure text with a cryptographic hash at last. So another thing that people easily forget is that nowadays, when you have a format, it's never alone. Files are layered, there is a lot of stuff that you can abuse, and one format may be robust against some attacks, but maybe the format outside or the format inside, or some format that is inside the same archive make the whole system vulnerable. And this is what we did for SHA-1, for Shattered. The first SHA-1 collision, it was on PDF files, but it wasn't a PDF collision. PDF parsers cannot reliably collide with SHA-1 because PDF parsers all have a very different use case, different supported features, so it's a very unreliable landscape. So instead, because JPEG was used the same way everywhere, we abused JPEG in a PDF because JPEG could be collided reliably. And by the way, that would also work with any format based on JPEG. So you have a normal, you declare a PDF, a standard PDF with a JPEG, and the JPEG is a little less standard, and the JPEG actually contains two different images, which will appear on the, depending on the collision content or not. Sorry. Another thing that we did with collisions is that I was asked, there is some European agency that is indexing Office files with MD5. What could go wrong? Well, Office files are made of XML files inside a zip. And it turns out that these two formats are very collision resistant because XML doesn't tolerate the binary randomness of collision blocks. Boil. Of course, nowadays we have text collisions, but that's very recent. And it's still you still have very little freedom. And zip cannot be collided generically because they have this bottom-up structure, which is against the top-down computation of collisions. And basically, the workaround around this was you abuse XMLs inside the zip, and you hide the collision blocks inside some zip structure that will not be a part of the archive. That's called the extra field. And therefore, you can manipulate XML inside the zip. The XML stays valid because XML parsers don't see the mess of the collision because it's not something that is extracted. And then, and this is transparent to the zip, so it works generically. And this is what I did for this inside-out presentation, providing generic prefixes that can be reused to instantly collide any Office file formats using the same XML structure. And libtif was released by tar JZip with the MD5 as a checksum for validation. And it's the same, tar cannot be collided generically because it has all this text-only header. And, but it turns out that JZip can be combined together, and basically you abuse the JZip structure so that when you decompress the archive, it will actually show a different tar file altogether. Which basically, you can take the same libtif file and whatever tar file you have, and they will be combined with weird JZip. And so of course, it could be a backdoored libtif file, but it could be just whatever you want. And this is transparent to all the tar system because it's hidden in the JZip structure. And a bit the same for the tar hashquines. Tar, again, cannot be collided generically, but we could do that with JZip, L4, or this standard archive structure to present basically, once the decompression is done, there is a different content that you completely control to external parser, and then any arbitrary tar file will work. That will be transparent. So it's hidden behind a layer of decompression. Now, we're in 2024, AI. Kind of hate and like it as much as you do, probably. But here, when colleagues started to work on AI, I was like, what can I truly be done, and what are its true limits? And we file format and AI, initially it sounded like a bad idea because like who needs AI when you need to check a magic signature? It won't catch polyglots. But when you have everything as an input as any kind of files, including binary and source, like any kind of attachments, then what do you scan with? What will you scan when you have whatever is attached? Is it a PHP? Sorry, PHP. Is it HTML, JavaScript, or is it a P file? Then how do you distinguish between binary format and source format all at once, efficiently? And this is exactly what we did. And we worked and we released a tool called Magica, which handles 200 file formats, as many file formats that we could find enough files to train on with a proper license. It's not a large model thing. It runs on the CPU. It just needs 1 megabyte of files. It's very fast. And nowadays, it's used in production at Google on hundreds of billions of files weekly. And it's used at least in 150 projects. Thank you. It's open source. It's public. There is a paper that was accepted at ICSE. And it's non-generative AI. It just gives a verdict. So there's no copyright infringement. And we work only on files we have a license for. So it's not the kind of, I steal all the rights of the artist, and it's like identifying stuff. Of course, it has its own limits. Oh yeah, sorry. And suddenly, by plugging Magica in production, we could see whatever is in people are exchanging right now. And then we don't see the whole thing, but we could see the verdict. And suddenly you realize, each community, Euro Truck Simulator, Minecraft, Dream Engine, whatever, gaming engines or whatever, weird files, people are exchanging. And it's PDB. Oh, you mean the Microsoft debug? No, Protein Data Bank. Oh, you need this kind, all this kind of format. And I think we learned the hard way that a good representation of the file format landscape is, what a mess. What a mess of messes. It's crazy. But Magica can somehow help just a little bit for now. So it's no silver bullet. It just scans the first and last 2 kilobytes of the files. And again, there are many formats we don't have enough samples to be able to train it on. And like any AI model, it has the usual limitation. You cannot edit or omit some stuff from the model. And it's trained on normal files, not my files. So it may fail on weird files, but it has, on the other hand, a good effect to be able to catch corrupted files or spoofed files. Spoofed files as in, I send you a corrupted Office document. It's not a valid file anymore, but very nice. Office will repair it from you, and suddenly it bypass security scanner, and suddenly it's active payload, and you're targeted by something that wasn't supposed a valid file in the first place. That's very common in software, and Magica is able to catch that because it sees something that looks like, it's almost a good file. So if you take a zip and you corrupt the usual PK signatures, then it's a bad file, okay. But still, it looks like pretty much a zip file. And that's one of the verdicts that Magica is able to help on. So it has its use case. It's not a silver bullet. It's new and different, and it's useful in its own way. And when we were working on Magica, we are planning to work on a new engine. Well, what exists out there? And this is exactly why I gave a talk on the topic, because I certainly looked at all the engines, the standard ones, but also the ones that you don't care about, to see where they are good at and what they can or cannot do, to see if there was a point for it, and if there is, and what are the actual limitations. And of course, fooling AI identification is very possible, because some formats already give you full control of the first bytes, but with Mitra, my tool, you can just say, hey, Mitra, give me some space, keep the file valid, and now insert whatever you want. And as I mentioned before, if you take a zip, you put some space, and suddenly you put a lot of PNG content, the start of the file is mostly PNG, so it makes sense that this file is seen as a PNG. It sounds stupid from a strict detection, but if you still wanted to carve a lot of files out, then it's useful, because after all, this file is not standard anymore. So the conclusion for all this mess of simple, complex, cryptographic, hash collision, file formats. Some stuff still works. Some specifications are still neither laughable, no reference code, no back-to-date. I still have the same experience when people start to look at the file format and they just go to check Wikipedia and they come with a very naive vision of the actual landscape. And then they discover about my files and they facepalm a couple of times. And then they'll read some other documentations and information. But that's the thing, right? They still go back to the original limited bad specifications. 10 years ago, I spoke about many funky proof of concepts. Nowadays, there are tools to make it work at scales. Lots more. I wouldn't mention all of them, of course. And they are used to create a lot of collision possibilities, a lot more polyglots combination, and also AI tools that works on quite a few files a week. I mean, tens of billions, hundreds of billions is a weekly figure. AI in file formats without hype or mystification. First thing, many AI formats are vulnerable because they were like pickle, protobuf. They can be abused. You can inject code in pickle. That's normal thing. Who cares? It's for AI. Who cares about security? Magica brings something new to the file format processing domain, but it has its drawbacks and advantage. At least, but it makes a difference in some useful way. Maybe not your usual, oh, I have a single file to check, maybe don't use file, Magica. But if you want to scan some traffic and quickly, then maybe it will be useful to you. And my tool Mitra can be used to inject arbitrary data in formats and full AI that way, but it was already able to do that. It's not necessarily for AI, but until now, most AI people were thinking in their attacks that not about keeping the validity of the file. They were just thinking about changing the pixels in an image. Just, oh, the cat is detected as a dog, but it's not about changing the validity of the file when you just change pixels. It will still be an image, but suddenly if you take a PDF or a PE file, then if you change one bit somewhere, then the file won't be valid anymore. But Mitra is able to help for that. So for the next 10 years, maybe, we could improve specifications writing and updating, the way we craft samples and sharing, and maybe cover more identification of formats and because some formats, like the Word document we saw earlier, are definitely not easy to identify, and also the way we classify files and rate them. I wrote a few commandments of the good file format. If by any chance you define a new file format before, I don't know, I get angry or I pull more of my hairs on it, maybe read a few information on that, but it's pretty annoying to see new file formats still defined like, oh, this is how we do traditionally. I would say, go the whole way. If you define the file format, do it like Microsoft in the 80s. That would be awesome. People will love you. And you'll be famous. Maybe go, go big or go home. If you want to do something totally useless, then go for it. Do it the old ways. So thanks for your attention for now, and thanks to the Fabianis. And do you have any questions?
What a beautiful talk! My polyglot heart is really warm right now. So we have up to 20 minutes of questions, and also questions from the internet. So please line up at microphones if you want to ask a question. I will start with microphone 2.
Hey, thank you for the talk. I'm not a security researcher, so I'm more like a developer. So I want to prevent those kind of problems or attack vectors. You mentioned attack vectors with which use polyglots where parts of the files are not parsed or interpreted, where then some malicious payload could be inserted. Would the solution to this be to parse or format check or even interpret everything, or at least like the header, in order to prevent such attack vectors? Thank you.
Exactly, there are possibilities. Can you hear me? Yeah. There are possibilities to rather than just extracting the value that you want to parse from a file, instead create a map of the file and look at what is a blind spot and see what is in those blind spots too. So like, but because basically when there is a polyglot, some part of the file is invisible to the parser, and that's the other file, the other payload. And basically, because no parser remembers, hey, I skipped some ranges here, maybe there is something to check. And this is actually blind spot checking, and this is still very new, and this is not necessarily AI. But one thing I said is that if you take a standard file and you cut, for example, the first 16 bytes, you run that into Magica again, the usual file types will maybe invalidated, but then suddenly it might see another file type. So actually, Magica can help that way. You wipe the signature, that is the obvious one, and maybe some other file formats will be detected in consequences.
Okay, let's see what the digital sphere has to say, and let's take a question from the signal angel.
All right. The internet wants to know whether crypto polyglots could be used by law enforcement agency for things like planting evidence.
Yeah, I mean, yeah, definitely, that's definitely a possibility. Even polyglots, but without the other key, then the content is really hidden. Yes, a bit like hash collisions, right? If I send a file that has this MD5, I know you're indexing files by MD5, I send you clean files with the picture you want, and inside there is another content. Yes, it's totally valid, but then if you look at the files from a structure perspective, it's very weird. But yes, the other thing will be encrypted, and that's totally a possibility with collisions or with crypto polyglots.
Now let's take a question from microphone. I think it's 4.
Hi, Angel. Thanks for an excellent talk again. 2 questions, one short up front. Do you know what file keep going does? The Linux or macOS command file -- keep going?
Yeah.
Because it also has a capability of analyzing polyglots.
Yeah, it just keeps a signature. Yeah, the one I use on Polymox. Yes, it would if there is signature, yes.
Okay.
And it could also do false positives. The classic example is then you look at, for example, a PDF viewer, which is an executable.
Yeah.
It has PDF strings inside the data, the code, and it will. It's one of the problems we have for POC or POC or GTFO actually, because yeah, the software we're thinking, hey, there is a PDF inside. No, it's just a PDF viewer executable.
Okay. The other thing is what would you recommend to developers for web applications for detecting polyglot images, if not using Magica? Is there an easy way, like shrinking or enlarging uploaded TIFFs, PNGs, JPEGs?
Usually the standard way to do so is just to extract the pixel and create the image yourself.
Okay.
And that's pretty safe, right? It's not what you asked, I know, but at least it's the safest way and the one you expect the best, you know. Hopefully the pixels don't create something too polyglotty.
Okay, good. Thank you.
It looks like microphone 4 is the only microphone with people, so it's microphone 4 again.
Do you have any real-world experience how content filters react to polyglots which are valid as different archive formats, like tar, enze, or if it clashes with a mine type in an attachment?
Yeah, usually there is always a way to bypass that. And I think very recently there was a bypass of security by concatenating 2 files, and one tool was seeing the first one and the second one. All tricks again. Thank you, archives.
Microphone 4 is the magic number. Again, microphone 4.
So you mentioned extracting pixel data as a safety feature. Would it be possible to create a file which is not a polyglot until you do that?
Yeah, I mean, if you know how the things will be controlled, yes, totally.
Because that would be evil.
Actually, I remember once I was asked, if you send something in clear, you had a lot of bytes with a high entropy, very likely the compression will keep that as a whole, and then whatever you put next will be kept as plain text originally without any compression. So basically you destroy the compression dictionary by doing that, and basically you interleave that with comments, and basically you have a valid after compression payload in source, for example. So that's probably that's doable.
Thank you.
It looks like all the questions have been answered. So let's give him another round of a big applause.
Thank you.
Thank you for being here.